Wouldn't it be cool to find something to do with all those optical drives laying around? Well, currently we're embarking on a project that will turn these into this, a CNC machine, or in this specific instance, we'll just call it a drawbot. If you haven't seen part 1, click here to see how to take the optical drives apart and assemble them into an X, Y, and Z axis. And now that you have your machine assembled, let's make it work. In order to do that, we're going to need some brains. And in this case, we'll be using an Arduino for that. It can be just about any flavor of Arduino that's available, but I'm going to be using an Arduino Uno because it's the most popular. Now, when it comes to our optical drive stepper motors, Arduinos have a difficult time talking to stepper motors directly. So to assist in this, you're going to need a stepper motor controller for each of our motors. And since you're going to have to wire the motors up to these, here's how you do that. These pins are the ones that go to the motor wires directly. And then these 2 pins are for power and ground wires, and we'll take a look at that later. And then these pins go to the Arduino. So for the Y-axis, they go to ground, pin 3 on the Arduino, and pin 6. And then for the X-axis, they go to ground, pin 2 on the Arduino, and pin 5. And then for the Z-axis, they go to ground, pin 4, and pin 7. There we go. So if the Arduino's the brains, you can consider these the hands and feet. So now all we need is the lifeblood, power. A quick and dirty but highly dangerous way is to use an old PC power supply. I scavenged this one from the same old PC that I took the optical drives from. But in order to make it work, we need to tweak it. Again, let me stress not to do this unless you A, know what you're doing, or B, have supervision of someone else that knows what they're doing. That said, let's carefully move on. So on a typical power supply, you have a mess of different colored wires. I won't go through all of them, but black is ground, red is 5 volts, orange is 3 volts, and green is power. A PSU won't turn on unless the power wire senses a load. So to bypass that, with the power supply unplugged, use a jumper wire to connect the green wire to a black ground wire. Then when you add power to the PSU, it should power on. But for now, let's just continue leaving it unplugged. What we need from here is to supply power to all of our different components. And to do this, we'll need a 5-volt connection and a ground connection. So I was able to run a jumper wire from a black ground terminal and one from a red 5-volt terminal, and then branch them out to all the different stepper motor drivers. The Arduino itself for now will be powered through USB. So with the PSU still turned off, let's load the software onto the Arduino. 3-axis machines like the one we're making run off of a programming language called G-code. By itself, Arduino can't interpret G-code, so we'll need to install a G-code interpreter called Gerbil. You can find the Gerbil website here, and it lists many different ways to install it on the Arduino, but here's what worked for me. On the Gerbil page, I right-clicked and saved the version 0.8c hex file for Arduino Uno. Then I also downloaded Xloader from this website to burn it to the Arduino. With your Arduino plugged in, open up Xloader, point it to your hex file, select the Arduino version that you're using, the COM port that it's plugged into, and then just click Upload. Once that's done, the next thing we need is to give ourselves a way to control it. And there's a free piece of software online called Gerbil Controller that you can download that will be perfect for what we need. I'm going to be using version 3.5.1 of this software. So with everything properly wired, power up your power supply and connect your Arduino to the computer. Then open up the Gerbil controller, select the port name for your Arduino, and click Open. Now we can use the arrows on the right to test out each motor. Just make sure the step size is set to 1. If any of the motors are moving backwards, you can go under Tools and Options to invert the axis. Pretty cool, right? So now all we need to do is figure out what we want to do with it. You could attach some type of drill to make a milling machine, a laser to make a laser cutter, or maybe even a hot end and extruder to make a 3D printer. But I'm just going to keep it simple and just attach a marker to draw stuff. Since the Gerbil controller only reads G-code, we need a way to convert images to G-code. A great website for this is makercam.com. Here you can add basic images or even upload your own. And to create a new image, go to Insert and select a shape. Using the arrow tool, select it and move it to the lower left-hand corner of the grid. Then you can use the hand tool to pan around to different areas of the grid. Switch the units to centimeter and then go to Edit, Scale, and scale it down so that it fits within the smallest corner box of the grid. Once that's done, go to Cam, Follow Path Operation. Set the target depth to -1, safety height to 1, and step down to 1. Then click OK. Then go to Cam again and select Calculate All. And finally, go to Cam one last time and select Export G-Code. At this point, you should just be able to go into your gerbil controller and under Send File, choose your saved G-Code. Then you should see the image appear on the right. Make sure that your axes are set to their 0 positions and then click the 0 position button and then click Begin. It may take a few tries to get the Z-axis depth right, but if everything moves smoothly, it only takes a little bit of tweaking to get it working properly. What would you do with the CNC machine like this? Or how would you make this one better? Let me know in the comments below. What idea would you like me to cover next? Submit or vote for your ideas at tinkernut.com/ideas. Click here to watch my last video, and if you'd like to support my show, please feel free to like, subscribe, comment, follow me on social media, or donate at tinkernut.com/donate. Alright, that's it for this tutorial. For more, go to tinkernut.com.